Okay, I'm Serguei. I am in the College of Pharmacy, but I'm not a pharmacist by training. I'm a computational linguist. Graduated from the University of Minnesota in 2000. It's been a while. So I'll talk about challenges for applications of generative AI in healthcare specifically. And I'll try to keep it kind of at a high level just because we don't have a whole lot of time. But one thing that, to start us off, one thing that I did before putting together this presentation is look at that report, the AI for Science report, and it struck me as one thing stood out for me, and this is what it was. So this you just saw it on the previous presentation too, the same slide. So this is directly from the report. These are the challenges that were identified for GenAI in deep learning. And this was about a year ago. I think these challenges still persist, a year later, right? So we're talking about generalization or generalizability of these GenAI models, handling of rare cases, availability of data, explainability and trustworthiness of the models, uncertainty quantification, computational efficiency and energy requirements for the models, for the training and inference, limitations of experimental design for scientific discovery, inability to engage in symbolic reasoning and decision making, right? And then, so that reminded me of something that I saw years ago. And this is what I saw years ago. Does anybody recognize this, by the way? It's generalization that counts. Data alone is not enough. Overfitting has many faces. Intuition fails in high dimensions. Simplicity does not imply accuracy. Feature engineering is the key. It's not that old, but it's oldish. So this is where it came from, right? So this was Pedro Domingo's article, right? Yes. Okay. So if you read the article, you'll see that all of these items, 1 through 6 below, overlap to a great extent with what we saw in that AI for Science report. Right? So we're kind of still there in terms of challenges, right? The one thing that, so this was published in 2012, just for reference. And so the two things stood out to me. So there's one thing that did kind of go away, right, with deep learning. So this feature engineering aspect, right? So we solved that problem. And then the one new thing that showed up, which is energy consumption, right? So we're consuming a lot more energy doing machine learning these days than we did 10 years ago. But we're still kind of in the same place in terms of these challenges, right? So just something to think about. Now, talking about applications of Gen AI in health, I sort of try to, and specific to the University of Minnesota, I try to organize this into these 3 areas. So the 3 main areas that we work on at the U in Gen AI applications in health, and one is medical robotics, where so for example, there's lots of applications of Gen AI in surgical robotics, where you can use, people are trying to use vision models to guide, surgical instruments through tiny blood vessels and, vascular surgery and things like that. And then there's lots of applications of Gen AI in translational bioinformatics. This is where we take scientific findings, fundamental research in animal models and human models, and then try to translate it into clinical therapies. And very exciting stuff is happening. Oh, I have 1 minute left. I'll keep going real fast, right? So we're talking about Gen AI models that model genetic sequences, and then using that for developing new therapies. And in clinical informatics, this is where Gen AI is used right now for things like ambient transcription of the conversations between the patient and physician, automatic documentation of these encounters, et cetera. So there's lots of different applications. The challenges, these 3 challenges here are not specific to health. They're common to healthcare applications of Gen AI and other applications and other domains, explainability and trust, validation and generalizability, ethical and legal challenges, so that's common to lots of applications. These are the ones that are more health specific, right? So we're talking about data quality, access, and interoperability. That's the area of healthcare is kind of plagued with this issue where the data is very difficult to access. There's a lot of privacy concerns. There's a lot of disparate systems all over the place. It's hard to train generalizable models. I'm almost done. So regulatory uncertainty, and you can talk to me, we can talk during the discussion session too about some of these and go a little bit deeper. But we have, problems like, it takes about 10 years for a new drug to be released to the public and be used in clinical care. Now imagine if you're developing a new AI model these days, and then it takes you 10 years to release it, so there's a bit of a disconnect there. Integration into clinical workflows, it's hard to figure out how well these models will play in the medical space because the development of these models happens typically outside or, doesn't really involve a lot of the clinicians and healthcare practitioners, so there's a bit of a disconnect there. And then the main thing that is important to me is this notion of skill atrophy. So if we were to place these models into practice and have these LLMs and what have you make decisions for the clinicians or help them make decisions, in time their skills would kind of go by the wayside unless there's a way to maintain them. So, and we can delve into more of this as we go along. Sorry for taking a little longer.